Howdy folks. What we're going to do in this video is we're going to try and figure out how to identify where a graph, some arbitrary function, f of x, h of x, g of x, y equals, some arbitrary function, we're going to identify where the graph is, concave up and concave down. Now, you may not be familiar with concavity, or maybe you have seen it before, but let me draw an arbitrary graph here. And let's say that we have some graph that does this. Let's say it does that. This is some graph, we'll call it f of x. And what I want to do is, we're talking about the shapes of graphs. And this is related to what we've done a couple lessons ago. And the idea here of concavity is related to the idea of increasing and decreasing and critical values. Okay? But here's what I want you to understand. My saying goes like this: up like a cup and down like a frown. Okay? And here's what I mean by that. Concavity is the shape of the graph, and there's two basic shapes. The curve can have a shape that looks kind of like this, that's like a cup, or it can have a shape like this, that's a frown. Okay? When the graph has sort of an upward curve to it, we call that concave up. Concave up. When it has a kind of a frown shape to it, it's curved downward, we call this concave down. Okay? And then there's one more possibility, and that's a place where the graph switches from concave up to concave down, and we call those inflection points. But I'll show you those in just a minute. See this graph right here? Starting here and moving all the way over to right about here. This graph is concave down. You can see that it curves sort of up and over, right? That's concave down. Up and over, curving this way, this is concave down. But starting here and leading all the way over maybe to right about here, the graph has sort of an under curve. It's under and up, right? This is concave up. And then starting here and coming maybe over right to about here, this graph is concave down. And then over here, the graph starting here and kind of curving up to here, actually right about here, looks like it stops right about here, is concave up. And then you can see that right about here, look what it's doing. It's sort of curving, it's sort of flattening out, doing kind of up and over, right? And so right at the end there, that graph looks like it's concave down. This is an important quality in calculus, the idea of concavity. And what concavity has to do with is the idea of the slope of the slope. The slope of the slope. And the idea of concavity, in order to identify the concavity of a function, concavity is related to the second derivative of a function. So if we had the function f of x, the concavity would be indicated by f double prime of x. What is the second derivative? That sounds really scary, right? Well, it's not scary. The second derivative of a function, very simply, is just you take the derivative, that's the first derivative, then take the derivative of the derivative, that's the second derivative. And concavity is really easy to identify if you already know how to make a sign chart. Because all you have to do to identify concavity is create a sign chart of the second derivative. If you can take the second derivative of a function and then identify a sign chart of the second derivative, you can identify concavity. Now let me talk about these points right here where the concavity changes from concave down to concave up and from concave up to concave down. Whenever a graph changes from concave down to concave up or from concave up to concave down, when the concavity changes, we call those inflection points. Inflection points. Inflection points. Okay? So, when we change from concave down to concave up, that occurs at an inflection point. That's where the second derivative switches from concave down. Well, the original function switches concave down. Well, let me get to that, okay? All right, so here's the idea. How do we identify where a graph is concave down and concave up? Well, I already told you we do it with the second derivative, and here's the basic idea. Wherever the second derivative is positive, the original function, f of x, is concave up. And wherever the second derivative is negative, the original function, f of x, is concave down. So, this place right here where the shape of the graph is concave down, we would say that the second derivative, f double prime of x, is less than 0. It's negative. And here where the graph is concave up, we would say that the second derivative of the function, so f double prime of x, that's how we say f double prime, is positive, greater than 0. And here at this point, concave down, that means the second derivative, f double prime of x, is less than 0, meaning it's negative. And here the second derivative is positive. And positive means greater than 0. And then way over here, our second derivative is negative because it looks like it's going concave down again, okay? And so now what I'm going to show you is once we have a sign chart of the second derivative, how can we identify where the graph is concave down, where the graph is concave up, and where there are inflection points. Okay, so here's our procedure. If you want to identify intervals where the graph of f of x is concave up and concave down, and you also want to identify the inflection points of f of x, here's your procedure. First thing you're going to do is you're going to find the second derivative of the function. Then you're going to make a sign chart of the second derivative. Then, wherever the second derivative, so you're looking at the sign chart, wherever the second derivative is positive, then the original function f of x is concave up. Wherever the second derivative is negative, the original function f of x, that's concave down. And then lastly, wherever the second derivative changes sign, it has to go from positive to negative or from negative to positive. It can't go from negative to negative, and it can't go from positive to positive. If that happens, there's no inflection point. So only the places where the second derivative goes from positive to negative or negative to positive, the original function f of x has an inflection point. And so here's an example right here. Let's say that we have some function. We take the second derivative. Once we find the second derivative, we identify, or we create a sign chart. And here's what we have. The zeros of the second derivative are negative 7, negative 1, 3, 5, and 10. Now, from negative infinity up to negative 7, the second derivative has a negative value. From negative 7 up to negative 1, the second derivative has a positive value. From negative 1 to 3, the second derivative is negative. From 3 to 5, the second derivative is positive. And from 5 to 10, the second derivative is positive. And then from 10 up to infinity, the second derivative has a negative value. And so here's what we want to do. We want to identify where f of x, the original function, is concave up, where it's concave down, and where it has inflection points. Well, with a sign chart, that's really easy to do. F of x is concave up on the intervals where the second derivative is positive. And there's 1, 2, 3 positive intervals from negative 7 to negative 1. So we'll put negative 7, put a parenthesis, to negative 1, union. From 3 up to 5, union. And then from 5 up to 10. F of x is concave down wherever the second derivative is negative. From negative infinity up to negative 7. From negative 1 up to 3. Oops, put a union there. Union. And then from 10 up to infinity. There we go. And those are the 3 intervals where f of x is concave down. Lastly, f of x has an inflection point at the following values. Well, the second derivative changes sign at -7. So at x equals -7, changes sign at -1, x equals -1, changes sign at 3, excuse me, positive, x equals 3. No sign change at 5. We go from positive to positive, and then there is a sign change at 10 from positive to negative. So the last one is at x equals 10. So 4 inflection points. Okay? And so this is how you identify the intervals where a function is concave up, concave down, and how to identify the inflection points of a function. So here's what you're going to do to practice is you take some functions and then just identify the second derivative, make a sign chart. By now you should be very good at sign charts. You just make a sign chart and then interpret the sign chart just like I just did, and you will be able to identify all this information. When you combine this with what you did in the last lesson, you can now identify everything you need to know about a function. You can identify where the function is increasing, decreasing, has a relative minimum, has a relative maximum, where it's concave up, where it's concave down, and where there's an inflection point. Okay? And that's everything that you have to be able to identify about a function without its graph, having only the analytical function itself. Okay? So let me know if you have any questions, and this should be you should be good to go after this.